the perpetual race, software updates and proactive defense. A narrative exploration of patch management, vulnerability hunting, and Google's Project Zero. Anatomy of the battleground, insights from the bug tracker. A glimpse into a live vulnerability ledger, such as Project Zero's open issue tracker, illustrates the startling diversity and architectural depth of modern software defects, rather than simple logic errors. Today's high-severity security bugs occur at the complex intersections of hardware, kernel space, memory management, and data parsing. Examining these real-world findings reveals where the modern digital perimeter is most fiercely contested. Kernel and hardware driver vulnerabilities. Hardware, drivers, and kernel modules operate with the highest privileges, making them prime targets for privilege escalation. Recent proactive research highlights severe memory corruption risks in these deep system layers. Out-of-bounds, OOB reads and writes, flaws in device drivers, such as mobile CPIF drivers, can allow an attacker to read and write kernel memory directly from userland, obliterating boundary protections. GPU ring buffer corruption. Complex graphical processing units, like Qualcomm Adreno GPUs, can suffer from ring buffer corruption, enabling adversaries to bypass protected mode restrictions. Race conditions in video drivers' asynchronous driver operations, such as Video Processing Unit VPU instance closures, can race against themselves, leading to fatal use-after-free UAF memory corruption. Operating system and core library flaws. Core operating systems and foundational open-source libraries underpin thousands of consumer and enterprise applications. Vulnerabilities uncovered here have massive blast radiuses. System server elevation of privilege in mobile ecosystems like Android. Unbounded recursion and missing stack probes in system servers can be leveraged for local privilege escalation LPE. Similarly, logic flaws in Windows administrator protection mechanisms can allow applications to bypass administrative boundaries. Parser integer overflows and memory corruption. Widely deployed XML and XSLT parsing libraries such as libsmol2 and libxslt frequently suffer from integer overflows, leading to heap buffer overflows, or use-after-free bugs triggered by internal key data corruption during document transformation. Cryptographic and session weaknesses. Even basic utility services, such as Linux CUPS printing systems, can introduce vulnerabilities if session cookies are generated using predictable or weak pseudorandom number generators, for example, relying on standard time-seeded random functions. Application and development tool exposures. End-user applications and developer tools represent the final link in the chain. Researchers continually find remote execution pathways in everyday software, ranging from development environments like Visual Studio Code having remote debuggers enabled by default, to BitTorrent clients such as uTorrent and transmission suffering from JSON RPC parsing flaws and integer overflows that allow remote code execution and sensitive information disclosure. Summary taxonomy of modern vulnerability discoveries. The following matrix categorizes recent real-world vulnerability patterns uncovered by proactive research teams, illustrating the technical mechanism and systemic impact of each flaw. Vulnerability category: kernel and hardware drivers. Representative component: CPIF, VPU, GPU drivers. Technical mechanism and impact: out-of-bounds read, write, and use after-free UAF due to race conditions, leading to full kernel memory compromise. Vulnerability category: OS privilege escalation. Representative component: Windows admin protection, Android system server. Technical mechanism and impact: unbounded recursion or application name verification flaws allowing unprivileged apps to gain system or root privileges. Vulnerability category core data parsers. Representative component libsml2, libsourced torrent parsers. Technical mechanism and impact integer overflows and heap buffer overflows during XML, JSON torrent parsing. Triggering remote code execution RCE. Vulnerability category system services and tools. Representative and Linux Cal Studio Code. Technical mechanism and impact weak. RNGC generation for session cookies and insecure default debugger configurations allowing unauthorized remote access. Conclusion, a collaborative future for cyber resilience. The ongoing evolution of software updates and proactive vulnerability research highlights a fundamental truth of modern technology. Cybersecurity is not a static state, but a continuous narrative of adaptation. As software systems grow more interconnected, the responsibility of securing them transcends individual developers and proprietary borders. By combining rigorous daily patch management with proactive, offensive vulnerability hunting exemplified by initiatives like Google's Project Zero, the technology industry can systematically eliminate critical classes of bugs before they are weaponized. Ultimately, staying current through software updates and actively seeking out hidden flaws are two sides of the same shield, working in harmony to defend our digital infrastructure against an ever-evolving threat landscape.
Bạn muốn học mạng máy tính nhanh hơn, hiệu quả hơn và có người đồng hành xuyên suốt? Khóa học mạng máy tính 1-1 sẽ mang đến cho bạn một giảng viên hướng dẫn riêng, xây dựng lộ trình học phù hợp với trình độ và mục tiêu của bạn. Bạn sẽ được thực hành liên tục trên các bài lab thực tế, rèn luyện kỹ năng cấu hình và xử lý sự cố mạng như trong doanh nghiệp. Với lịch học linh hoạt, hỗ trợ tận tình và tập trung 100% vào sự tiến bộ của từng học viên, bạn sẽ tự tin chinh phục chứng chỉ kỹ sư mạng quốc tế và sẵn sàng bước vào sự nghiệp quản trị mạng doanh nghiệp. Khóa học mạng máy tính 1-1 học đúng trọng tâm, thực hành chuyên sâu, sẵn sàng cho công việc thực tế.